A very good morning to all the students who are attending summer training sessions on using Simulink. I welcome you all. Simulink is the most used engineering software package in today's world. It is used for modeling, simulating, and analyzing the behavior of dynamic systems. Now, what is Simulink? This is our lecture 1, in which we will learn how to start with Simulink. Simulink is the graphical user interface that is integrated in Matlab. Its primary interface is a graphical block diagramming tool and a customizable set of block sub-libraries. As it is integrated in Matlab, we need to install Matlab on our PC in order to use Simulink. Now, how to use Simulink? First, we need to define time-varying systems including communications, controls, signal processing, video processing, and image processing by mathematical equations. These equations may be linear or differential or difference equations. And then we implement these equations using graphical block diagrams by drawing block diagrams on the canvas provided in the Simulink. We will define systems, simulate them, and analyze their response. Now, Simulink can also be used to simulate linear and non-linear systems with continuous or discrete time characteristics. Please note, Simulink can also communicate with Matlab workspace and functions as well as with user-written programs in other languages. So, data can be bring in from the Matlab workspace. Also, data can be exported to the Matlab workspace. The simulation results can be sent to the Matlab workspace for further processing and visualization using the Matlab graphical tools. This introduction will cover how to start with Simulink, how to manipulate the basic blocks in signal lines, how to add comments, annotations, and run simulations in block diagram based Simulink software. So, Simulink use a block diagram approach. In Simulink, we draw block diagrams for defining systems. A block diagram is an interconnection of blocks representing basic mathematical operations and are equivalent to systems mathematical model. The lines which connect the blocks together represent the variables for describing the system behavior. We can select function and blocks in Simulink and draw the block diagram, and here we need to just enter the values of the variables of the mathematical equations representing dynamic systems. Now, how to start with Simulink? First of all, you need to purchase Matlab and install it in your system. Now, click on the Matlab icon present on the desktop. Otherwise, type Matlab in the search bar. Okay, then you will find this Matlab run command. Click on this template Matlab run command. It may take some time to open up because it is a heavy software. Now, when we will click on Matlab run command template, the previous action brings up the Matlab home page. Okay, this is the Matlab home page. I'm showing you the Matlab 2016. This is the home page for Matlab 2016. Okay, now you can see there are so many Matlab menus. This is the Matlab home page tool strip. So many toolbars are present. In order to start Simulink page, to start working with Simulink, click on this Simulink icon from the Matlab home panel tool strip. Simulink button, Simulink icon in the Matlab toolbar, or alternatively we can type Simulink in the command window and then press enter. This action will open up the Simulink editor window or blank model window where we can draw our block diagrams. So before that, the previous action will open up the Simulink start page. Actually, the Simulinks, this is on the screen, we can see the Simulink start page. When we click on the Simulink icon or type Simulink in the command window, we will be able to access the Simulink start page. This is the Simulink start page. It offers us different options to do different tasks. If we want to create a new model, we will double click on this blank model template in order to open the blank model window, also called as Simulink editor window. Now, few more things. There are number of built-in examples present in it, which can be accessed by clicking on this examples tab. This is examples tab. When you click on it, you can have access to various examples, and to run those models we need to double click on them. Okay, now click on the blank model. See, opening Simulink may take quite a lot of time because it's a heavy software. Now click on the blank model to open the Simulink editor window or blank model window where we can draw our models for simulation. Okay, now this is the Simulink model editor window or blank model window. This is the canvas where we can draw our block diagrams representing dynamic systems. So we can create our Simulink model here with blocks. Now, how to access these blocks? To access these blocks which are present in the Simulink library browser window, we need to access that window. To access the Simulink library browser window, to open it, click on the library browser button in the toolbar of Simulink. This is the library browser button present in the Simulink toolbar. Click on it to access the library browser window. Okay, Simulink is far better than other previous simulation packages that need to formulate the equations into a program. While in Simulink, we can choose a function and blocks and just need to enter the values of the variable of the equation. The Simulink library browser also provides us waves, functions, models, various toolboxes and other useful tools required for simulation. Now, when we click on this library browser button, we can open up the this is the Simulink library browser. When we click on it, Simulink, this Simulink library browser button, we can have access to Simulink library browser. But before that, I want to tell you that few more things, that suppose after creating a model in this window, we need to create another model. Then we need to click on this new model toolbar icon. In latest version it is called as create model icon. In the older version it is called as new script button. So we have to click on it, new model toolbar icon, in order to open a new model or blank model window where we can draw a new model. Okay, now if we want to open an existing Simulink file, we can enter the command in the Matlab. We can, for example, we can enter, if it is saved by a particular specific name, all the files must be saved by a specific name. So we need to type filename.mdl, or in latest versions Simulink saves file with .slx extension. So we can type filename.slx. Now if we alternatively, we can open the model file by hitting Ctrl+O, and if we want to create a new model file, we can also use Ctrl+N. Okay, now this is the blank model window. This is an unsaved project, unsaved model. Okay, so this is an unsaved model having a default name untitled. You can see its default name is untitled. So if you make any changes into this model and you do not save it, all your changes will go wasted. So first of all, we need to save the open model so that we can access it sometime later. For that, for saving a model file, click on the File Simulink menu. Okay, this is the Simulink editor window. These are the Simulink editor window menu bar, and this is the toolbar of the Simulink editor window. So from the Simulink editor menu bar, click on the file, then click on the save as, and then a dialog box appears, and where in the file name text box, enter a desired name for your model. For example, simple model, sine model, amplification model, sine.slx, and then click save. Simulink saves model files with .slx or .mdl extension by default. Okay. Fine. Now moving on to next slide. So save the project, your new model file, in the directory we wish. So we have to save a new model built-in Simulink editor window by clicking on file menu, then save as menu, and then we need to provide a location and name for the model file. Model file names must start with a letter and can contain no more than 63 letters, numbers and underscores. The file name must not be the same as that of Matlab command. Now there's one more way by which we can access the Simulink library browser, which contains various blocks and toolboxes. We click on the View Simulink menu. We can see that this model file is saved by a name intro. So this is the blank model window, or you can say Simulink editor window saved by the name intro. Now click on the view menu, then library browser to access various blocks or any other toolbox required for your simulation. Okay, this is another way. Now moving on. So I repeat, clicking on this Simulink library browser icon present on the Simulink editor window toolbar. Okay, click on it. You will be able to access Simulink library browser window. This window will open up, which contains so many blocks to simulate various systems. So on the left side, we can see there are various libraries, subsections, or you can say categories. For example, commonly used blocks, continuous, discontinuous, discrete, math operations, sources, sinks. Sources and sinks are very oftenly used. So these are the sub-libraries, different categories. When we click on a sub-library, then on the right side we will be able to see the blocks which are present in that particular sub-library. For example, if we click on the commonly used blocks, then on the right side we will be able to see the blocks it contains. For example, this is a gain block, constant block, logical operator and block, integrator block. Okay, now how to create a model. For creating a model, first step is we need to select desired blocks. Select desired blocks from the library browser and place them in the model window, blank model window or Simulink editor window. We need to place them. Now how to place them, that I will tell you in lecture 2. The first step is select desired blocks. For example, select gain block from the math operations sublibrary, select integrator block from the continuous sublibrary, output from the sinks library. Okay, now we need to modify the parameters of the blocks to correspond with the system we are modeling. For example, if we place a gain block into the model, then we need to set its gain value. This can be done in the block parameters dialog window. To open the block parameters dialog window, double click on the block and it will give you an option, a gain field box, where we can enter the desired gain value by first deleting the default value. Every block has default parameter values. Okay, integrator block, its parameter is initial condition. We have to set the initial condition parameter for integrator block. Output block, we have to set the port number for parameter for this block. Now, how are these blocks characterized? These blocks, Simulink blocks present in various sublibraries, are characterized by input ports on the left side, output ports on the right side, a specific name and a specific symbol, or we can say icon. This open triangle on the left side indicates the open triangle on the left side which is entering the block, indicates the input port. This small triangle on the right side which is leaving the block indicates the output port. This is the name of the block. 1 by S is the Laplace transform representation of the integration. Now, specific name, input output ports and a specific symbol, 1 by S. Okay. These are few more useful blocks: math and control sublibrary, integrator, state space, transfer function to solve various differential equations, transport delay, add, gain, product, sum. Inputs and outputs blocks. The input blocks such as constant, ramp, pulse generator, clock, sine wave, step are used to generate data or to provide input signals. Okay, these blocks are present in the sources sublibrary. The blocks scope and XY, these are the output blocks. They are used to visualize the simulation, output simulation result. These blocks are present in the sinks sublibrary. Now, these are few more Simulink blocks, and these are the graphical symbols: gain block, summer, integrator, trigonometric functions, sine, constant, clock signal for generating a mux multiplexer, scope to visualize the output data, output waveform, to workspace, step signal to generate the input signal, one-dimensional lookup table, and user-defined function. Okay, so all these blocks need to be connected with other blocks with lines. The lines represent signals with time varying values. Okay, very important thing. All standard blocks in Simulink have detailed help. So, first you open the block parameters dialog window by double clicking on the block. Now here, suppose if you have an integrator block and you have placed it onto your model, then double click on the integrated block. This section will bring the block parameter dialog window on the screen. Here you can see there is help button. When you click on it, you can have all the knowledge, detailed information about the block, so you can know what function will it perform. Okay, now as you can see, gain block, it multiplies incoming signal by a constant value. Summer, it adds or subtracts multiple signals. Integrator, it integrates incoming signal. So we need to set the parameters of the blocks. For that, we double click on the block. For example, if we are using a gain block, its gain value must be set. If we are using a sum block, the number and signs of the inputs must be set. That is, we have to add two signals, we have to subtract two signals. So we need to change the signs. Okay, and if we are using integrator block, we need to change its initial condition. We need to set its initial condition and then simulate it. So this is all for today's lecture. We will continue in the next lecture. I will tell you how to manipulate blocks, how to connect them, how to run simulation in the next lecture. Thank you so much for patient hearing.